Hi everyone. Today we were talking about building the graph of tangent and its inverse. We first started in class by talking about how tangent is defined, and several of you drew a right triangle. In fact, we started off with this statement that the tangent of a reference angle of pi over 3 radians equals root 3 over 2 over 1 over 2. And this led students to draw diagrams such as a reference angle with pi over 3. And then we know that tangent of an angle is defined as the opposite side, according to that angle, over the side adjacent to that angle. And so a lot of students wrote their triangle as root 3 over 2 being the opposite side and 1/2 being the adjacent side. Some students went ahead and noticed that, hey, if we consider simplifying this, and I like to think of this as just if we multiplied by 2 over 2, then we would just end up with root 3 over 1. And that would just equal root 3. So some students identified that you could also have side lengths of root 3 and 1. As long as this ratio is satisfied, then we can consider that a ratio that applies to the reference angle of pi over 3. Now, this representation is a diagram that allows us to visually see this statement. However, it is limited because we know that there are other angles that will give this same ratio or an equivalent ratio, such as root 3. So one thing that students drew to represent that reality is that we can draw triangles in any of these quadrants with a reference angle of pi over 3. And in fact, we can consider a tangent value because we have that opposite side over the adjacent side. We know that this could correspond to a vertical length over a horizontal length. Or if we're thinking about this in a coordinate plane, the vertical length is our y coordinate, whereas our horizontal length is an x coordinate. And so you could think about this as tangent of theta equals the vertical length over the horizontal length. And of course, in a coordinate plane, that means that the tangent of theta is simply that y, that vertical length of y, over x. And if we were specifically talking about this ratio or an equivalent ratio, that would produce root 3 in the third quadrant as well, because we would have a negative y value over a negative x value. However, just a note, in quadrant 2 and 4, it would have to be the negative square root of 3 to produce the same result. Then we considered how in our unit circle, how this would apply as well. And we consider that right triangle. Now, in a unit circle, we know that this hypotenuse length is 1, whereas in this reference angle diagram, you are considering a circle potentially with a radius of n. And so in this case, we could think of tangent as simply the, if we're thinking about the x and y values, then in the unit circle, that is also defined as the cosine of whatever angle we have and the sine of theta. So we currently have 4 different ways of defining tangent. You have the tangent of theta equals sine of theta over cosine of theta as well. Now in class, we also made a connection that because the sine of theta is the opposite side over the hypotenuse and cosine of theta is the adjacent side over the hypotenuse, that if we set up the ratio, that connects back to the opposite over adjacent, because you would have tangent of theta equals opposite over whatever that hypotenuse is, and adjacent over the hypotenuse. And however you want to simplify this, you know that this is going to be equivalent to opposite over adjacent because these hypotenuses will divide to equal 1. And so if you think about I kind of just think about it as multiplying by the hypotenuse over the hypotenuse. And that will give me the opposite over adjacent, hence making this full circle idea. And it also works with this diagram, because if you had your y length and your x length and you considered the sine and cosine way of doing it, then you're kind of, this would be, let's see if I have enough room. It would be y over n over x over n to represent the sine of theta, cosine theta for this reference angle diagram. And so again, we just see that that is equivalent to the opposite over adjacent. So lots of ways to justify that relationship. And then what we're going to do is we are going to build the tangent graph based on that. So mostly what students did was they started off with these strategic values of this rotation of 0 degrees, pi over 2, pi, 3 pi over 2, and 2 pi, except you know that we have negative pi to pi. So you have to think about this as negative pi, 0 to negative pi, and then we have 0 to pi as well. Now, so what students did was they said, okay, at an angle of 0 radians, then this coordinate is 1, 0. And so when we calculate the tangent of 0, we know that that is going to equal 0 over 1. And hence, we know that at this, remember this axis represents our radians, whereas this is going to represent the ratio. That value is going to be 0, 0. Now, when you look at this pi over 2 value, which is what students did next, you noticed that we have this coordinate 0, 1. So the tangent of pi over 2 radians is 1 over 0. So they identified that that is undefined. Now, I know it's undefined, but I'm not going to do anything with that because we need to figure out if it's undefined. We have to look specifically at the behavior around it to figure out what's going on around that input of pi over 2. So then I'm going to go ahead and kind of skip that for now and think about what if I had my angle of pi over 4, my angle of pi over 6, and my angle of pi over 3. And what I suggested in class was that you make a table of values. So if we're thinking about an angle of rotation, and we need the sine of that angle, the cosine of that angle, and then the tangent of that angle. This is a great way to organize your work. So what you identify here is that you have your 0, 1, and that your tangent is just 0 over 1, which equals 0. And then at pi over 2, we knew that that was 1, 0, which gave us that 1 over 0, which was undefined. Now, if we go ahead and think about pi over 6, pi over 4, and pi over 3, then we can start filling in those sign values as well. So here we would have 3 pi over 2, I don't know why I said that. This would be root 3 over 2, 1/2. So that is sine would be 1/2. And cosine would be root 3 over 2. And then we have 1/2 over root 3 over 2. So 1/2 over root 3 over 2, which simplifies to 1 over root 3. And then we get root 3 over 3. So if I think of root 3, I know that's going to be approximately like 1.6 or so, 1.6 over 3. So that's going to be about 1/2. This would be an appropriate time to use your calculator to figure out an approximate value. So we have root 3 over 3, and then figure out an approximate value. At pi over 4, we know it's going to be root 2 over 2, and root 2 over 2, which of course is going to be 1 if we divide those. That tells us we can plot this point at 1. And then this point, again, was at about 1/2 when we were at pi over 6. So that's about 1/2. So we kind of see that taking place there. And then if we look at pi over 3, that will be root 3 over 2 for sine and 1/2 for cosine. And so that gives us root 3. And again, that's approximately 1.6, 1.7. So at pi over 3, I kind of just think of dividing this into thirds. Then we get about 1.7. And again, you need to kind of think about what is happening around pi over 2. So the way that I like to think about this is I think about a right triangle that is getting more and more extreme. So we had pi over 6, which is 60 degrees, and we're trying to think about, what happens as this angle of rotation gets to 90 degrees. So one thing that you can kind of look at are the behaviors. And if you think about this value, thinking about a unit circle here. Oh, that's sloppy. Let's redo that. Okay, so we think about our circle here. We think about this value is getting closer and closer to 1. This opposite side is getting closer and closer to 1, while this adjacent side is getting closer and closer to 0. So if you think about a right triangle, say a right triangle where we have like an 89 degree measure, we have something that's really, really close to 1. And then we have something that's really, really close to 0. And through our investigation of rational functions, we know that if we take a number, like let's say it's 0.999, and we divide by a really, really small number, say like, I don't know, 0.0001, we're just estimating here, that's going to be a huge number. So around pi over 2, that means it's shooting off to infinity. That means we have a vertical asymptote, and you can now draw that behavior. Now, you can kind of do the rest. You know that the same idea is going to happen at negative pi over 2, except we know that we will have a negative x value and a positive y value in quadrant 2. Or rather, sorry, we're looking at quadrant 4. So if we go from 0 to negative pi over 2, we have positive x values and negative y values, which means tangent is going to be negative. So we can start plotting our points in the same way. Like, for example, at negative pi over 4, we get a value of negative 1. And we're going to start seeing this behavior take shape. Again, same idea with if we're approaching negative 1, we have negative 0.99999, and then whatever that adjacent side would have to be. By the way, you can solve for that since you know your hypotenuse and your opposite side using the Pythagorean theorem. But we know that due to our that behavior of rational functions, that is going to approach negative infinity. And so you'll need to continue that idea to get the rest. If you look at pi here, that was what I was talking about with the negative x values but positive y values. And at pi, you know that it's going to be 0 over negative 1, so that's 0, and then we know those values will be negative. Can sketch in those values. And then at negative pi, right, between negative pi over 2 and negative pi, you're going to see that at negative pi, it's going to be 0, of course. It's the same value as at pi, but these x and y coordinates are both negative. So hence, it's going to shoot, they're all going to be positive, and it's going to shoot off to positive infinity. So that is the idea of tangent. In the next video, I'll go ahead and briefly cover inverse tangent. Again, just a reminder, make sure that you investigate and make sense of this on your own as well as listening to the video. Thank you so much for listening, and stay tuned for the next one.